Well, good morning. Guys, what we got here is asskicker base station. It's a 1 drive and 4, and it is broken. Imagine that, it's here to get fixed. So we went through and we identified the problems, and now we're in here repairing them. So what we have here is the remnants of the output transformer, the output combiner. It got so hot it split and snapped the ferrite. And this is our pad that sits between the 1 pill and the 4 pill section, or 10 ohmer. And let's move around here to the inside. There's a couple things I don't like. The power wire is not rock star, but it's okay. But we've come in here and we've replaced the output combiner. I built a new one and replaced the resistor. It was burned up. Replaced the input resistor. Now I got to replace the resistor that runs from here to here. I'll probably just put a piece of wire. Might need to modify the input tune. When I see this, I always get a little leery. But it is a 1x4. Now, it does not have bias on it. It's just a delay, which is down here. It's just a delay. Oh, no, wait a minute. It's here. I lied. Here it is. That's the delay circuit. It's got a fairly decent rectifier on it. Fairly substantial heatsink, and it's an iron core transformer power supply. So I've got the, I pulled both the transistors out. This is the one that popped. And this is the one that was paired with. This has got a gain of 32. And this is the transistor I'm going to replace it with, which has got a gain of 33. So they're matched. So I'll slap that back in there. And then in theory, this thing should take off and run. The one other thing I'm going to do to modify this is there's this big gaping hole that's down here. Big gaping hole down here that just lets the air run right out. And the other thing I'm going to do is I'm going to lay another screw. I'll punch a screw through here, and I'm going to put a tab to hold this corner of the heatsink down, so I don't have to worry about the thing flexing. But I'm going to cover this hole up to force all the air to go across the heatsink. This is like a Sweet 16 heatsink of some kind, I do believe, because it's black anodized. So force the air to go across the heatsink and out the cabinet instead of just running out the hole at the side. So, but then we're going to pump it up. I'll get those 2 transistors in there, and we're going to look it through the pass-through tune. I always get a little leery of preamp circuits when they've got long leads on them like this, to where you're going to have an input imbalance. So we'll look at that on the KC901 network analyzer. We'll shoot that and we'll see what we've got for a pass-through. But there's a bunch of little things I'd change in here, but that's not the point. The point is just to make this thing work. Now, unfortunately, I've got to say this. The gentleman that owned this amp, he sent it to me, and in the time of it sitting here, he has passed on. So now the widow has asked me if I'd be kind enough to help her liquidate this thing. So it's going to be up for sale once I get it finished. All that aside, let's get on with the show. So away we go. Let's put the transistor back in it. Let's make sure everything's running. I'm going to double check everything, and then it'll be out the door. So give me just a minute. I think when we cut back, the transistors will be in it. The circuitry will be back together, and we'll be having a different conversation about how we can go about looking at the pass-through tune on this thing. So be right back. Okay. So now what we're metering now is the ability for the RF to come in and pass through the device and go out to the antenna. That's what we're looking at. We're looking at the pass-through SWR, the pass-through standing wave ratio. Okay? So we got the 901 up here running. And it's telling me, we look over here, it's a 1.6, and that's at 25 megahertz, and over here at the center delineator is at 27, so this is going to be about 30 megahertz or so. We've got up here 1.6 all the way across the board. So let's go in and fix that. What you want to have is it down below 1. And the reason for that is the as your RF comes down off your antenna and passes through the cabinet, you want to make sure your tune is as flat as possible passing through the cabinet. Otherwise it'll affect your receive, and then when you have the amplifier off and you're trying to just operate the radio, it's going to give you a false reading back to the radio. It's going to tell you that your SWR's got a high antenna when it doesn't. It's actually the amp. So I'll fix that. We added our little blocker in here to keep the air moving the way it should. We added our little support bar over here, which will keep our heatsink from flopping back and forth. Because the only other place that had any support was all the way back here. Which, that's broken off. So let me get in there, I gotta fix that too. That's gotta be grounded. So give me just a second. So I got that soldered back down. As I'm standing here working on it, I noticed that we're missing something here. So let me slap a nut on that and make sure that doesn't ever back out. That's way better. Now we're down to a 1.07, 1.09, so less than a 1.1. All the way across the funny pan. It all comes from knowing where to put the cap in just the right spot. Okay, so let me get out the Variac, and I'm going to run this thing up real slow. We're going to check all our voltages on it, and then we're going to check it out running. Remember, guys, my basic goal here is to make this thing stay about as stock as possible from when our buddy down there built this thing, so it has the highest resale value. I don't want to go and put my fingers all up in it and change everything. It's not what we're after. So let me hook up the Variac, and we'll give it a whack. We'll see what it does for power. It's probably going to scream because it's on an iron core transformer. All right, guys, give me just a second. 19.7 volts. Hello. So 1000 watt PEP, 1000 watt average, 5 watt second reverse. Input tune. Hello. It's good. Output power. Hello. 700 peak watts. Hello. Pulling to 14.5. Hello. Couple hundred bird. We's a little low on the output power. Output power a little low. I think I'm gonna pull this attenuator out, the voltage divider out. Pull that out and check our output tuning capacitors. I have a feeling that might be what caused all of this to happen with these two caps right here. Be right back. Now across those two terminals, that should read 150. That reads 40. So let's see, 150 and 1,000. That'll get us 126, 125 puff for the output tune. Yeah. I'm going to change that. I think, actually I know for a fact, that cap breaking down is what caused all of this to happen. Cap got hot, cap broke down, fell out of resonance, the output tune fell out of resonance. Guy kept keying it, trying to figure out why his output power fell down. He probably pulled the tin a couple times, looked around, couldn't see anything burned up in it. Kept trying to talk on it, and because this cap doesn't have any physical deformities to it, he kept running it, and boom, it blew a pill because the circuitry is trying to talk into an unbalanced load. Bada bing, bada boom, and now it's here. And he finally probably quit keying it when all the smoke came out. Oh shit, there's something seriously wrong. This is going to cost somebody a couple $100s to get fixed, and it comes down to what, a 35-40 cent part. Bummer deal. Anyhow, let's get it running. You'd be amazed what a proper little bit of tuning will do for something. Okay. This little box talks. I changed out the cap. I went with a higher KVA. I brought it up instead of having it laid down. This is almost double the KVA. This is like a 2 KVA cap versus that other one was a 1000 volt cap. And I'm barely tickling this thing, you guys. So we're on 12 volts. I'm using the 2950. Let me turn the power supply off here. Okay, ready? Watch this. Hello. Hello. Really? Discharge. Hello. It's still trying to key up. Watch. Hello. It's off, right? There's still 4 volts in the capacitors. Hello. So you can hear the relay chirping a little bit. Okay, so check it out. Putting like 10 watts into this thing, right? I fixed the variable, by the way. That was all messed up. Preamp is working, and sideband delay is working now. 700 watts to, let's take the multiplier and go up since we're barely off the scale. We're now in the 2,000 watt setting, so right here is going to be 1,000 watts, you guys. About 1,300 watts peak envelope power, just like that. Turn the receive up on the radio. Preamp is working. Sideband delay is working. This thing's back. It's 100% again. It's transmitting in fine style. So I changed out this cap and it came up to 1,000 watts, right? So then I came over here and I replaced the voltage divider that was in here, what everybody calls an attenuator, and it took off like a rocket ship. I was like, oh, there it is. So, guys, it's done. And like I said, this thing's going up for sale. The widow's got to see $800 or $900 out of this at least. So, if you're interested, shoot me a text, and as soon as it's sold, I'm going to put it up there. I'll change the title on the video to sold. So, you guys know how this works. Anywho, you gentlemen, have a good day. Appreciate y'all tuning in, and let's see if we can get this on down the road to a new home. Gentlemen, my name is BBI, and without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. Come find me on Facebook, Twitter, Snapchat, and of course right here on the YouTube Gargler. If this is your first time watching, please, for the love of God, click subscribe. If you've enjoyed what you've seen, just click like. Doesn't count for anything in this universe anymore, but a little bit of love never hurt nobody. Okay, guys, I got to get on to the next project. Oh, and by the way, this has got 2 voltage regulated fans on it. 2 voltage regulated 120 millimeter fans. And of course, then it's got the 2 pot metal fan guards over here. Sheet metal, so. Asskicker, 1x4, 1500 watt, 1500 base. It does have a curl in the corner of the cabinet here. Other than that, this thing is pretty much dent free. Give me a shout. Let me know if you want to get it. I'll talk to you later. Bump, bump. BBI gone.